Okay, there are 4 reasons for doing electrolysis. We've already looked at recharging batteries, so this is a really quick overview. The next 3 videos are going to be looking at the other reasons. The main thing with discharging and recharging batteries is the anode. So you should know what the process is that's happening when discharging is occurring and when recharging, and what polarity the anode and cathode are. Okay, so the one to remember is spontaneous reaction. When the batteries are working, the anode is negative. So once you work that out, then all the rest of them you can work out from it. So the cathode would be positive for spontaneous reactions when the battery's working, and then when you're recharging it, it would swap. So if we looked at a battery, when a battery's working, the anode, the negative end of the battery, is where the electrons are coming from, and the positive end of the battery is where the electrons are going to. So the negative end during recharge, that's the anode, discharge I mean, and the positive end is the cathode. So oxidation's occurring here, reduction's occurring there. So if your battery's flat, these symbols can't be rubbed off the battery, so you need to attach a power supply and force the electrons back into here. So because you're doing that, the power supply is where the electrons are coming from. It's acting spontaneously, so that end's negative, the other end's positive. So the negative end of the power supply is attached to the negative end of the battery, so it's negative to negative when you're recharging a battery. Your power supply must have a voltage that's higher than the battery. So if it's a car battery produces 12, it's a 12 volt battery, so your power supply should be 14 volts at least or more. If it's another car that you're using the battery of, then you should be running your car. It should be working whilst the battery is recharging the flat battery of another car. Okay, we've looked at this in chapter 5.4. This is just a quick overview. In a car you've got a lead acid battery, sulfuric acid, lead metal and lead oxide are on the plates alternating. So these are the 2 half equations for it. You can look in chapter 5.4 if you can't remember how to do this. So the main thing is if you're given discharge equations and you're asked for the recharge equation, you get the overall discharge equation. So the electrons are being lost from the lead. It's forming lead sulfate on one plate, and the electrons, so they go over to the other plate, over to the lead oxide plate. It undergoes reduction. It forms lead 2 plus ions. There are 4 plus here, so 2 plus ions, and it also forms lead sulfate. So the 2 plates have lead sulfate on them. So if you want to recharge it, it's just the reverse. The 2 plates with the lead sulfate, the electrons are going to be forced off one plate, and it will form lead oxide, and forced onto the other plates, and it will form lead. So just the reverse. So you just do the overall discharge equation and then flip it over, and you've got the recharge equation. Okay.